let me quickly show you what we are going to build in today's exercise lesson. Okay, I have prepared an example which looks like this. Let me start it. Here it is. Let me make it a little bit larger. As you can see, we are simulating here machines, let's say, machines with some sensors in it. Of course, the sensor values that you see here flying around are artificially generated, so they are not real temperature sensors. I call them temperature sensors. But a user can, for instance, click through here and can say, I would like to monitor this sensor and I would like to remove this sensor. And you see, we see every second or so, or every half second, we see new measurements. And I have already prepared a class which can generate those artificial values. But I ask you to use your imagination. Imagine that this would be some kind of machine monitoring system where these values come from physical sensors built into the machines. We gather this data and we want to display that in a kind of bar chart. And whenever this value, in this case the temperature, is too high, then the bar is red. And whenever the value becomes too low, the temperature becomes too low, it also is displayed as red, as you can see it here. You see that our random generator is using a sinus curve. So the values are not just random, because that would look a little bit strange. So I decided to go for a sinus curve, but it's completely artificially generated values. If you take a look at this user interface, you will see a lot of things that we have to fulfill, or that we have to implement with XAML. For instance, we need to turn our values into this bar chart. We are not going to use a bar chart component for that. We are going to build that from scratch. We need some kind of panel that does this visualization in our dashboard. Obviously, I think by now everybody should understand that. It's a wrap panel, so that we can make this window a little bit larger or a little bit smaller. We have a list box here on the left hand side. It's a multi-select list box with which we can add or remove sensors, of course. And I think that's it. We have to display all the sensors. We have to display all the values. That's essentially the thing that we are going to do today. As I said, this sample contains a lot of repetition regarding data binding and templating of things like data templates and item panel templates, but it contains some additional new things that you might not already know from XAML, and I hope it will be useful. It will definitely be useful in your upcoming exams, homeworks, or final year projects, or whatever you do in practice. Okay. The sample is completely implemented. I implemented that for you yesterday, but we will build the sample step by step. You will get the sample code for the sample data generator from me. It is available over internet, and I will give you this sample code. But everything else, we will write it together so that we can make sure that everybody really understands the code and what's going on. I ask you to follow along so that it's not that boring. So please start up Visual Studio and create a new project here. This project should be a WPF application, a WPF.NET Core or .NET 5 application, and I will call it, here it is, Machine Monitor. Please call it Machine Monitor 2 so that you can copy in some sample code that I give to you. So let me zoom in a little bit. Oh, I didn't start my zooming tool. I'm sorry for that. Let me do that here. So let me zoom in a little bit. So please choose the project name Machine Monitor so you have the same namespace as I have. And now we are good. So this will give us an empty WPF app, and everybody by now should be familiar with the structure, should be familiar with XAML, so we don't need to repeat that. The first thing that we are going to do is we are going to copy in the sample data generator, and this sample data generator can be found in this gist here. Here is the gist. I will copy this link into Discord so that you don't have to type it in. Give me a second. I will copy this into your Discord. Here it is. Okay, please check your Discord server. You should see the gist there. And once you opened the URL, you will get some sample code, and I ask you to copy the entire sample code and create a new class, and this class is called temperature sensor. And there you can just paste in the whole code, and I will quickly walk you through. I'll just wait a second until everybody could copy the code from Gist. Okay, let me quickly walk you through the code. It's an artificial temperature sensor. It's not really a sensor, as I said. It generates values. It has some important constants here. First, the amplitude, as you can see here, is 300. That means that it generates values between 0 and 300. That's just, yeah, whatever. An artificial value, you can change that if you want. And there is a period. This period is the number of milliseconds until the sinus curve will repeat the rhythm. So every 20 seconds, the sinus curve starts new. Okay, that's just so that we have some interesting values and that it looks nice. Okay. The implementation itself is really trivial. The application just calculates the number of milliseconds that passed since the creation of the temperature sensor, and then applies a little bit of math to use the sinus function to generate a value that is between the amplitude and 0. Okay, that's the only thing. And the value that is returned consists of two things. It is represented by the record temperature reading. On the one hand side, it's the value, and on the other hand side, it's a Boolean value, which is called is critical. And this is true if we are in a critical temperature area. Critical means that either the temperature is too low or too high. And as you can see it here, we have the business logic for finding out whether the temperature is critical. Reading is greater than 90% of the amplitude or lower than 10% of the amplitude. I ask you to take a close look at this expression, because this is pretty new stuff, which is only available in the newest version of C#. So this is so-called pattern matching. You see how this is written? I use the is keyword here, and I use the or keyword here. This is a really nice way of writing such expressions. Reading is greater amplitude multiplied by 90% or amplitude multiplied by 0.1%. Please note that this syntax is only available because amplitude is a constant. If amplitude would be a variable, this syntax would not be possible, and you would need the classical reading greater equal and then the typical logical or reading lower than and so on. But this kind of so-called relational pattern matching is available for constants, and this is just a constant. It's not super important what I told you now. It's for those of you who are really interested in syntax of programming languages. This is, as I said, pretty new in C#, and I think it's readable and it's maintainable, and I really like this syntax. If you write it differently during the test, that's fine. Visual Studio will tell you that you could rephrase it, and yeah, it's not super important, but it is kind of interesting to know. Okay, this is our temperature sensor, and we are simply going to use it. Good. Close it. Try to rebuild your app. It should compile without errors, without warnings. We are good, and we can get started. So let's go into our main window, and the first thing that we do is we are going to write a little bit of C# code, okay? First, let's store a temperature sensor in a local variable. Okay, so we will do a private read-only temperature sensor, and let's call it sensor. Okay, and in the main window we are going to fill this sensor equals to new. It gets no parameters, as you can see it here. And what is the next thing that we are going to do? We are going to set the data context here to this. I hope everybody can remember. Let me quickly repeat what that means. When we do data bindings in XAML, the data context will be the source for all our data bindings. And we will store variables inside of our main window class. And by setting the data context to this, to main window, we can bind to every property inside of our main window. Now let's store the list of values that our temperature sensor returned inside a collection. Public list of. So what will the temperature sensor return? Let's quickly check. It will return temperature readings. So list of temperature reading. Let's call it temperatures, something like this. Let's do it get and initialize it. That would be a property against which we can bind. What did I do wrong? Is list a good data type for data binding? When we add temperatures behind the scenes, exactly, observable collection. Right, observable collection is the correct data type for doing data binding. Don't get me wrong, observable collection is only necessary when the content of the collection regularly changes. If you have a collection whose content does not change over time, you can easily use a list. Then you don't need an observable collection. An observable collection is important whenever you have a collection where the content changes regularly and you want to update the user interface based on the changed content. Good, nice. Now we need to use our temperature sensor to gather data. And for that, we need a so-called timer. We need a timer. A timer is something that ticks every whatever milliseconds, and we can use it to ask the sensor for the current value. .NET knows lots of timers, and for WPF there is a specific timer which plays very well with the whole .NET and WPF infrastructure. And this timer is called dispatcher timer. I will not go into the details about the differences between timers. They are important, these differences, but you can remember for WPF, dispatcher timer is often a really good option. So what we are going to do is we are going to create private read-only dispatcher timer. Here it is, dispatcher timer. We will create a new dispatcher timer. As I said, all the other timers are fine too, but some of them require extra work, and dispatcher timer works like a charm when it comes to WPF. It has some drawbacks too, but we will not go into details. Maybe next year when we do more advanced user interface development, then we can talk about how WPF solve this thing. For us now, this is a really simple setup. We just say timer.interval. This is the first thing that we set. And we say timespan.from milliseconds. Let's say every half a second, we would like the timer to tick. Every 500 millisecond tick, 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 the timer will send us an event. And this event is called tick. Now we can do two things. On the one hand side, we can say timer tick plus equals and press tab, and then .NET will insert a private method here, and we can add the code here. That is one option for writing it, and you can do that if you want. On the other hand, we can also use a lambda function, something like underscore underscore. That means we are not interested in the parameters that we get inside of this lambda function. You can also give them a name, it doesn't matter, we don't need it, we can simply ignore it. And the underscore means ignore the parameter. And here we can now get the temperature from the sensor. Var current temperature. equals to sensor dot get temperature. That will give us the current temperature. Then we can temperatures insert at the beginning, insert at index 0. We can add the current temperature to our collection of temperature readings. And finally, the collection would grow and grow and grow and grow endlessly. We will make sure that we only store, let's say, the most current 20 readings of the sensor, because it doesn't make sense to store the temperature readings for hours and hours. That is just an arbitrary requirement that I place here. So what we will say is we'll say while temperatures dot count greater than 20, temperatures dot remove at, we remove the last, meaning the oldest entry that says temperatures dot count -1. Understand what I mean? We are just making sure that we are deleting all temperatures which were inserted. Let's rephrase that. We are removing all temperature entries that are older than the most current 20 elements. Okay, that is what we do. Essentially, while is just a safeguard, we could say if too, that works too. Just to make sure, if we screw something up, while will make sure to remove everything at the end. The last thing that we have to do is we have to say timer.start, and that will make sure that our clock starts ticking. So the timer will now run, and behind the scenes, it will every 500 milliseconds get the temperature from the sensor. By using the observable collection, we can now use data binding against our temperatures collection, and the user interface will be updated automatically because, as I said, we are using an observable collection. For those of you who are deeper into software development and user interface development, you might ask yourself, the timer is a kind of background process. Well, it is not, because dispatcher timer, this one here, is running in the same process as the user interface. So you don't have to think about handling multiple threads or things like that. It just works. It's just fine. Okay, so don't worry about it. As I said, we will not deal with the details here. Any questions regarding this timer stuff here at the beginning? Should be pretty clear, right? With that, we can switch towards the XAML file. Here we have the XAML file, and we are going to implement our user interface first. Now, the first thing that I would like to implement is this nice little chart. We are currently just having a single sensor, and we will work our way up to multiple sensors later on. But first, I want to display the data of a single sensor, and let's make that one at the beginning very, very simple. I ask you to use a so-called items control. Items control is a control which is similar to a list box. You all know what a list box is. The only difference is that in an items control, you cannot select an item. It just displays a list of elements. Otherwise, it behaves very much similar to a list box, okay? Items control, as I said, it's just like a list box. And we can bind with the items control to a property, and I hope you can remember that. We had it multiple times in the last few weeks, and it's called items source. The items source will give us the possibility to control the content of the items control through a binding. So let's go for item source, and let's just say binding, and here we bind against which property? Against the temperatures property. This is what we want to do. We want to display all temperatures. And inside of the items control, I hope you can remember that we had this display member path property where we can choose out of the temperature reading here what we want to display. And for instance, we can display the value in order to see the values that come out of our temperature sensor. So that would be a very, very simple display of all the temperatures. We can give it a try. Let's run it in the debugger. The app will come up and hopefully, nice, we will see our temperature readings. And if I take a look at the values here, they are really behaving as expected. As you can see, the values are gathering, and once we have 20 values, the values will be dropped at the end. So we always have the most current 20 values. I don't see any value greater than 300 because that was our amplitude, and I don't see any values lower than 0 because that was the lowest value, the minimum value of our sample data generator. And if I take a look at the values, they also grow out slowly towards 300, then they are falling down to 0. So I can imagine that this is something like a sinus curve. I think you get the idea, right? Okay, that works. Does anybody have a problem so far with the data binding or the SAML? Pretty simple stuff here. That is definitely something that you have to be able to write at the test. So you have to be able to build a property. You have to choose the correct type, observable collection. You have to be able to use an items control or any derived controls like list box or combo box. And you have to know that there are two important properties, item source and display member path. Now let's quickly take a look at the solution that I prepared for you. I will run it again and then we will analyze it. So this was the solution that I prepared for you, and this is what we are trying to achieve. So if I zoom in here a little bit, let me do that, something like this. If you take a look at what we have here, now this could be, or we could imagine that this is our items control because it displays a list of elements, a collection of elements. So this is our items control. However, it differs in two things, in two aspects, very critically to what we currently have. First, in our implementation currently, the values are displayed top down. So the newest value is on the top and the oldest value is on the bottom. Here, the values are differently aligned. Here, we have not a vertical alignment, but we have a horizontal alignment. The oldest value is on the right-hand side and the newest value is on the left-hand side. That's the first thing that really changes. And the second thing is we are not using double values and print them as a text block, but we are using, as you can see it here, rectangles to display each item. So if you can remember what we did last time, we had two important aspects for data binding in XAML. The first one was the items panel template, and the second one was a so-called data template. I presented to you both things. Now, the alignment of the values, not vertical but horizontal, is what? A data template or the items panel? Just the fact that we have the values not stacked vertically but stacked horizontally. Which mechanisms would you use? Data template or items panel template? Correct. Items panel template, I would do that too, because we have to exchange the normal stack panel, which stacks values vertically, with the stack panel that is configured to stack the values horizontally. And then for the second question, for turning the double values into rectangles, only one feature remains, and that's the data template. So let's do that, okay? In practice, you will probably go into our exercise, into our coding exercises and copy some code from there. But here during the lecture, I I can just show you the code. Let's start with what you proposed with the items panel template. So this worked like that. We immediately get IntelliSense from Visual Studio telling us that items control.items panel would be a good idea here. Let's do that. It suggests us to use an items panel template, so we don't have to remember that. Visual Studio is smart enough to tell us, hey Rainer, that would be a good idea to use that here. And then we want to exchange the items panel. We don't want to use a stack panel where we see each thing stacked on top of each other vertically, but we want to have a stack panel where the things are stacked horizontally, and therefore we are going to use a stack panel with orientation horizontal. This is what I would like to use. And this simple change already changes our user interface drastically. If you see that one, okay, the values currently don't have any distance between them, so we don't really see, we can't really read the values anymore, but you already see that this is no longer stacking our values in this direction vertically, but it's now stacking the values horizontally. And this is exactly what the stack panel with orientation equals horizontal was all about. So that was our first thing. We already did that last time. This was just a repetition, but don't worry, the new things will come. The second thing that we can do, and please stop me or tell me if you need more time to follow along, okay? The second thing that we have to do is we have to use the data template. If you check the code in the documentation or our last week's lessons, you will see that there is something which is called an item template. This one, the item template. And there we can specify a data template. And now comes the interesting stuff. So far, we have only used data templates to display, I don't know, fancy texts, or maybe we used RoboHash to implement some kind of, I don't know, smart image generation where we used something to generate an avatar, but we can do more interesting stuff. We can really go in and say, let's turn the temperature value into a rectangle. Rectangle is just like any other thing like button or text block or text box. We can also define a rectangle here. This rectangle should maybe have a width of 20. I just say that it should be a width of 20. Yeah, I just define it like that. We can say the height should be, let's just check that one. The height should be a binding of the value. Let's just use the value in a raw way and display a rectangle with a height between 0 and 300 pixels. Last but not least, let's say fill, and let's use lime. I like this light green, but you can choose, of course, any color that you like. And maybe let's do a small margin here. On the left-hand side, we are going to define a margin of, let's say, 1 pixel. We don't need a pixel on the top. On the right-hand side, 1 pixel, and we don't need a pixel, a margin on the bottom. Let's try that one. Let's see if turning this one, this data template, turning this into a data template, if this works. Let's see. Let's run it. Oh yes, you see, I screwed up. We cannot set both display member path and item template. This is something that I regularly do. Unfortunately, I always forget that because you can either use display member path or use the item template. It doesn't make sense to use both things at the same time. I'm sorry I forgot that one, so please get rid of the display member path because now we have a data template. Let's give it a try again. And as you can see, we already get some bars. Okay, they don't make a lot of sense here because they are aligned incorrectly. They are currently aligned centered, vertically centered. So we get some interesting charts. Maybe this is somewhat usable. But of course we have to change that because our bar chart should be aligned to the bottom. But it looks already pretty nice. So what we have to do is we have to vertically align bottom, we have to vertically align the chart to the bottom, and we can rerun our application and see what's going to happen. And woohoo, we have our chart. We are not at the end now, but this is kind of interesting. We have not done any kind of graphics so far, and you have now seen that WPF supports graphic primitives like rectangles and lines and so on, just like any other control. So if you want to display some business chart or something like this, you can do that pretty easily with WPF. But don't get a wrong impression. If your charts or your graphics become more complicated, then those controls, rectangles and so on, are not the best choice. If you want to have high performance graphics with really complicated images, maybe even games, then these constructs are not usable. They are more for the typical business graphics where you only have relatively few graphic primitives, like a few rectangles, a few lines. For some business charts and so on, that's perfectly fine. But don't start implementing computer games with rectangles and lines. There are better options than that in WPF or any other UI technology. But for a business graphics like that, it's perfectly fine. Everybody could follow along? Everything clear? Very good. The only thing that we are going to do now is we are changing things like that, fill and width and margin and vertical alignment, and we are going to move it into styles. Quick repetition, you can go into window.resources at the beginning of your XAML file, and there we can define a style for the target type rectangle. This is what we essentially need. And let's give it a key. Here, key. Let's call it chart bar. Okay, yeah, let's call it chart bar. And here we need a bunch of setters. We want to set the property width to value 20. And in order to save me a little bit of typing, I'm going to copy this line a few times so that I don't have to write so much. So I will go to the property fill, and my favorite color here is lime. And I want to change the property margin, and I will copy the value from down below. So let's see here, you see, I'm just copying these values to do all the styling in styles and keep the XAML file of the view logic clean. Vertical alignment should be bottom, and the last one, I don't need it. And with that, I can get rid of all these things. You see, delete them and delete the fill and delete the margin and delete the vertical alignment. All I have to do is I have to say the style should be, can you remember what we need? Static resource. This is what I wanted to repeat. Style equals static resource, and there we choose the chart bar. And with that, we are using the style from up above here inside of this to style this rectangle. So we have all the visual appearance nicely encapsulated in this style here, and we have the logic of building the structure of the UI isolated down below. So styling should be here, the view structure should be down here. Let's try it. If it still works, and well, it still works exactly as we wanted it to be. If I don't hear any questions, we are good. We will now make a short break because we are already working for an hour. And after the break, we are going to start with some new things because we now have to find out how we can switch the fill color of the bar chart to red whenever we have a critical temperature reading. And there you will learn something completely new. We have not talked about that. So after the break, we are going into new topics. Up until now, this was just hopefully an interesting exercise and just a repetition of what we already did. Good. Let's make a 10-minute break. So now it's 5 minutes before 9. Fetch coffee or something to drink or a snack or whatever, and be right back at 9:05. 5 minutes after 9, we are going to continue. Okay? Good. See you in 10 minutes.